We've cooked hot dogs using line voltage on other demos to show the dangers of unisolated high voltage. This is pretty dangerous. We previously showed a prototype hot dog cooker using safe isolated control. We've made improvements for this video. There are still safer ways to cook a hot dog, but this shows how NVE components can be used for power control. These types of circuits are useful for power conversion, battery charging, and motor control. Hot dogs let us see and hear power transfer. The previous version had a filter capacitor to drive the hot dog with low ripple DC. That doubles the maximum hot dog power, but it creates large surges that could trip breakers, and the capacitor stays charged with dangerous high voltage. So we have a full wave rectifier that provides 120 volts RMS, still plenty for a hot dog. A silicon carbide FET modulates the voltage. Cooking is controlled by an Arduino. The Arduino shield has an isolator to separate the Arduino from the FET high voltage. And one of our DC to DC converters provides an isolated 5-volt supply to power the isolator and an isolated 9-volt gate supply. This isolator can drive some FETs directly, but we have a separate gate driver for this FET. There's also a beeper to signal when the hot dog is done. So let's cook. A cooking profile is defined in the Arduino. The cooking power starts high, then decreases to avoid burning. Here's the Arduino program. The cooking profile is defined in an array. We switch the FET off and on, and there are procedures for when it's done cooking and for when a fault is detected. It's done cooking. Parfait. This circuit has a single FET, but it's also extensible to H-bridges as we demonstrated in other videos. Here are the key components we used in this video. Stay tuned for our next video. We're planning to add a current sensor to prevent overcurrent and regulate the total cooking energy, because no one wants a hot dog fire. Click, email, or call for more information. We relish helping engineers beef up their power controls.